All right, so this is the first problem that you sent me. 1 cup serving of spaghetti with meatballs contains 260 calories and 32 grams of carbohydrates. A 1 cup serving of chopped lettuce contains 5 calories and 1 gram of carbohydrates. Determine how many servings are required to obtain 400 calories and 50 grams of carbohydrates. So we're looking for servings of spaghetti that would be required and servings of lettuce that would be required. So I'm going to define those as my variables. So x equals servings of spaghetti and y equals servings of lettuce. Okay. Now, I know that for the spaghetti, it has 260 calories per serving. So that would be 260x. That's how many calories would be in the spaghetti, depending on how many servings you have, 260x. I know for the lettuce, it's 5 calories per serving. So that would be 5y. Remember, we defined x and y as servings of spaghetti and y is servings of lettuce. So 5y would be the amount of calories in the lettuce, depending on how many servings you have. And all together, I want there to be 400 calories. So what I do to set up an equation, I take the number of calories in my spaghetti plus the number of calories in my lettuce, and that's just right here. Number of calories in my spaghetti, number of calories in my lettuce. Add them together, and that is going to equal 400. That's what I want all together, 400. Okay, that's for my calories. I can also set up another equation because it also gave me some more information. It said there's 32 grams per serving in the spaghetti, 32 grams of carbohydrates per serving in the spaghetti. So I can set that equation up. I can go 32 grams of carbohydrate per serving of spaghetti. That's how many carbs are in your spaghetti, depending on how many servings you have. For the lettuce, it says we have 1 gram of carbohydrates per serving. So I can go 1 gram of carbohydrates per serving, 1y. And I know when I add those up, it needs to be 50 grams of carbohydrates. So I'm going to go ahead and add those up right now. 32x, that's the grams of carbohydrates in your spaghetti, plus 1y, that's the grams of carbohydrates in your lettuce, equals, and it has to equal right here, 50. That has to be what it's going to be all together, 50. So I'll put a 50 over here. And there you go. This is your system of equations that's going to allow you to solve for x and y. And you're going to have several different options to solve this. You can do elimination, you can do substitution, or you can graph. It just depends on what he told you to do. I'm going to go over here to the left and use Desmos and graph them. Okay. But if he told you to do substitution or elimination, make sure you do those methods. If you don't remember how to do those, just let me know and I'll show you. But I'm going to go over here and I'm going to type them in exactly as I see them right here. So I have 260x plus 5y equals 400. Then I come down, I put my second equation in, 32x plus 1y equals 50. And let's see what we got here. They're kind of close together. So I'm going to zoom in until I see them. Then I'm going to try to find where they cross. Wherever they cross, that's going to be the solution. Let's see if we can find that. Sometimes it can be hard on these graphs to find out exactly where it crosses. Kind of zoom out a little bit. Okay, so if I touch on it, I'll see these two little gray dots appear. It crosses at one of those dots. So let's see if I can find it. That right there is just x-intercept. That's not what I want. There it is. Right there is where they cross. And if I zoom in, you'll see it. Right there. You really got to zoom in really close to see where they cross, because the graphs are pretty much right on top of each other. But it doesn't matter. 1.5 and 2, that's going to be your solution. X equals 1.5, y equals 2. So it says right here, how many servings of spaghetti would be required? Well, X was servings of spaghetti. X is 1.5. So that's going to be 1.5 servings of spaghetti. And Y is, what do we say? Over here it's 2. So Y equals 2. Y is servings of lettuce. So it's going to be 2 servings of lettuce. And that's going to be your answer. Okay. And you could, again, you might have to solve that with elimination or substitution, but that's okay. You should get the same answer, 1.5 and 2. And you could, of course, plug these back in just to make sure it all works out, but it should. In fact, let me do it real quick. 260, that's going to be, yeah, that works. So we're good. That's your answer. Okay. Going to go to the second one. Let's see what we have here. The coffee counter charges $7 per pound for Kenyan French roast coffee and $6 per pound for Sumatran coffee. How much of each type should be used to make a 20-pound blend that sells for $6.65 per pound? Okay. So what I'm going to do here, I'm going to set up a table. And what I'm going to label it is, let's see what we have here. We have 2 types of coffee, Kenyan French roast and Sumatran. So I'm going to go Kenyan French roast and Sumatran coffee. And I'm also going to have a mix, because I'm going to mix those up. So I'm also going to have a mix of the 2, because I'm going to take this and this, I'm going to mix it. That's going to be my mix. And I'm going to have a table. I'm going to put some values in here. For the Kenyan French roast, it said it's $7 per pound. So it's $7. Well, I don't know how many pounds, do I? So I'm going to call that X. Okay, so X is, I'll label it here, pounds of Kenyan French roast. And Y, by the way, is going to be pounds of Sumatran coffee. I'll just call it SC Sumatran coffee. Okay. And now if I multiply these together, It's $7 per pound. X is the amount of pounds. So if I multiply this together, 7x is going to be the total cost for the Kenyan French roast. For the Sumatran coffee, it's $6 per pound. Again, I don't know how many pounds I have, so I called it Y. And if I multiply it together, I'm going to get 6Y. That's going to be the total cost of Sumatran coffee. Now for the mix, and I'm going to get the mix information from right here. How much of each type should be used to make a 20-pound blend that sells for $6.65 per pound? 20-pound blend. Remember right here, these are our pounds. I didn't know this, so I called it X. I didn't know this, I called it Y. But I know this, it's 20 pounds of the mix. So I'm going to put that right there, 20 pounds. And if I look right there, it says that it's $6.65 per pound. And I'm doing this right here as the cost per pound. So I'm going to put my $6.65 per pound right there. And I can multiply these right here together. 6.65 times 20. 6.65 times 20 is 133. So, actually, it's did I say 133? Yeah, 133. Okay. So that's going to be the total cost of your mix. We're going to have 20 pounds at $6.65 per pound. It's going to be $133. But now I can actually have my equations. I can set up some equations here. For this column, there's no equation to be set. I don't have any x's or y's, but look right here. X and y, this plus this equals 20. The number of pounds of this coffee plus the number of pounds of this coffee, I'm going to mix them together, and when I mix them together, I'm going to have 20 pounds all together. Okay, this mixed with this, and at the end of it, I'm going to have 20 pounds. So it's going to be X plus Y equals 20. That's one equation. And my second equation is right here. I have X's and Y's. The total cost of this coffee plus the total cost of this coffee, when I mix it together, is going to be the total cost of my mix. I mix this and this, add it together, I should get the mixture. Okay, so it's going to be 7x plus 6y equals 133. That's your system of equations. And just like that last problem, you can use that to solve for x and y. Again, you might have to do substitution. You might have to do elimination. Or he might allow you to graph it. I'm not sure what he's requiring. I'm going to go over here and graph it. But again, if you have to do it some other way, go ahead and do it. You might have to do it algebraically. Don't remember how to do that? Just let me know and I'll show you. So I'm going to type them in. X plus y equals 20. And then I have this. 7x plus 6y equals 133. So I just typed it in exactly as I see it. And where they cross will be your solution. So I'll zoom out till I see my graphs. And I zoomed way in on my last one, so I got to zoom way out. There it is. And there's where they cross, 13 and 7. So x equals 13, y equals 7. And let's use that to answer my question. Right here it says the coffee counter should mix how many pounds of Kenyan roast coffee? Well, Kenyan roast coffee was X. X is 13. So that's 13. And how many pounds of Sumatran coffee? Y was pounds of Sumatran coffee. Y is 7. So that's going to be 7 pounds of Sumatran coffee. And always do a little quick check. X plus Y should be 20. Well, 13 plus 7 is 20. And of course, if I put in 13 here and 7 here and add these together, it should be 133. And there's no reason to doubt that it will be. And it is. So we're good. That's your answer. 13 and 7. And let's go to my next one. I think. Let's see if I can get there. Oh no. Hold on. Where am I at? There we go. Oh, I thought it was all locked up and I was going to lose everything. But we're good. All right. So let's go to my next one. Ah, what is that? Let's get rid of that. There we go. Okay. So on this one, Chris can be paid in one of two ways. For plan A, he can get $310 per month plus a commission of 8% of sales. For plan B, he can get $469 per month plus a commission of 5% of sales. For what amount of sales is Chris better off selecting plan A? Okay, so we're going to set up two equations. For plan A, he gets $310 per month plus a commission of 8% of sales. What that means is every month he gets $310 no matter how much he sells. If he sells nothing, he's going to get that $310. If he sells a ton of stuff, well, he's still going to get that $310. So that doesn't depend on how much he sells. He's going to get that every month. But he's also going to get 8% of his sales. 8% is a decimal, 0.08 of his sales. 8%. Well, how much did he sell? Do we know? No, we don't know how much he sold. So we're going to call that X. So his pay has two parts. $310 he gets no matter how much he sells. And in addition, he gets 8% of his total sales. Okay? And we're going to say that equals his total salary, which we're going to call Y. Or his total income, which is Y. The plan B, he gets $469 per month, no matter how much he sells, plus 5% of his sales, which is 0.05x, because I don't know how much he sells, and that's going to be his total income. So there we go. There's your system. We can use that to solve the equation. Now this one, it's much easier to see it on a graph because I'm going to show you how to interpret the graph to kind of see which one's better for Chris. So let's see. Let's type those in here. 310 plus 0.08x. Let's see if I can find it. Oh, I guess I have to put equals y. I didn't think I had to. There it is. Okay, so I got that. Hold on a second. Let me kind of zoom in here. What do we say? 310. Okay, so there's the first one. 310. I'm just going to hold on one second. See if I can change my settings. Let's do, you don't have to do this. Yeah. Okay, we'll keep that for now. And then I'm going to type my second one in. 469 plus 0.05x equals y. That's my second equation. And there it is. Now, these will cross at some point. I'm not quite sure where. They're getting closer. So I need to find out where they cross. And are they getting further apart? No. Hold on one second. We're going to find it. Well, it's not over here, is it? Nope. Okay, it's fine. That's the x-intercept right there. That's not what I want. Is that it right there? I'm just finding out where they cross. Okay, there. Where do these things cross at? Hold on 1 second, I'll find it. Let's see where they cross. Zero, that's not it. Nope. Oh, you know what I did wrong? Don't do what I did. I was like, well, what's going on here? Look at that. You see that 0.08? Man, I didn't put my X after it. So I got to put my X right there. That makes all the difference. So, yeah, I forgot my X. Don't do that. You'll waste a lot of time like I just did. All right. Now I can find out where they cross. Much easier. Where it should be. Let's see. Where do they cross? There they are. Okay, it crosses right there. Right there. So it crosses at 5,300 and 734. Now that's not your answer because it says, for what amount of cells is Chris better off selecting plan A? Remember, this is plan A and this is plan B. Now, you can't see it on the graph because I don't have it zoomed in right, but plan B initially is better than plan A because it starts at a higher value. It starts at 469, whereas plan A starts at 310. But eventually, plan A will come out on top. And the question is, where will that happen? So plan B starts out higher initially than plan A. But as you can see, plan A goes up faster than plan B. So eventually plan A will surpass plan B, and it's going to happen at that point of intersection at 734 and 5,300. So for what amount of cells is Chris better off selecting plan A? That 5,300 on your graph. When cells are greater than $5,300, that's going to be your answer. When cells are greater than 5,300, plan A will be better than plan B. And that's found at your point of intersection. Okay. So the reasoning there was plan B starts off at a higher amount. It starts off at 469, whereas plan A starts at 310. So initially, when he doesn't sell very much, plan B is better. But as you can see, plan A goes up faster, that's your slope, than plan B. So eventually plan A will surpass plan B. And where will it happen? It will happen when cells are greater than 5,300, which is, you find out by finding your point of intersection. Okay, but that's your answer. Alrighty, let's see. Oh no, didn't mean to do that. Oh, there we go. Okay, let's go to the next one. All right, so we have a goldsmith has 190 grams of gold alloy, which is a mixture of gold and one or more other metals, containing 70% pure gold. Let me kind of, come on, let's bring you on over here. There we go. Containing 70% pure gold. How much pure gold must be added to this alloy to obtain an alloy that is 75% pure gold? Okay, so here's what we're going to do. I think a table would probably be best here. And I'm going to label it amount, percentage. I think this might be best to a table. We'll see. Amount, percentage, total. Sometimes it's not very much information and table really doesn't help too much, but this might be. Okay, so we have a goldsmith has 190 grams of gold containing 70% pure gold. So I'm going to put that in there. He has 190. The percent of gold is 70%, which is 0.70. And if I multiply those together, I get 190 times 0.7. That's 133. So let me show you what that table is showing you. This is the amount. This is the alloy. It's a mixture of gold and another metal. He has 190 grams of that. 70% of it's pure gold. So if I multiply them together, I have 133 grams of pure gold. Now, let's keep on reading the problem and see what it says. Let me try a different pointer out. Let's try that out. That's cool. Okay. So then we have 190 grams of gold. We already did that. How much pure gold must be added to this alloy to obtain an alloy that is 75% pure gold? Okay. So what he's going to do, he's going to add pure gold to this. Okay, he's going to add pure gold. I just said this is the pure gold. Okay, he's going to add something. So he's going to add pure gold to that mixture. Okay, so that's your mixture, 190 grams, and he's going to add a certain amount of pure gold. And I can also put the X over here because remember the 133, that's pure gold. And he's going to add some more pure gold. Okay. So the reasoning, that's the mixture. He's going to add something to the mixture. And what he's adding is pure gold, but it's going to be a certain number of grams. So the mixture now is going to be 190 plus the extra amount of pure gold he added. But I can also put this X over here because 133 grams was pure gold of the 190. And since he's adding pure gold, he's also adding a certain amount of pure gold over here. And when it's all said and done, he is going to have 75% of his end product, 75%, which is 0.75, is going to be pure gold. And right here, oops, I didn't mean to do that. I meant to use my little thing. I can add these together. So it's going to be 190 plus X. He started out with 190 grams of alloy. He added some pure gold, so it's 190 plus X. 75% of it is pure gold, so I can multiply all this, just like I did up here, to get this. I can multiply these two together to figure out how much pure gold is in my mixture. And I'm just going to write that over here. It's going to be 0.75 times 190 plus X. Okay. And now I just look for my equations. Here's an equation. Well, actually, there's only one equation here. The equation is this plus this has to equal this. 133 plus this equals this. And the reasoning here is in his initial mixture, he had 133 grams of pure gold. He added X grams of pure gold. So 133 plus X has to equal this, which is how many grams of pure gold is in his final mixture. Okay, so 133 plus X equals 0.75, 190 plus X. Okay, that's the equation I have to solve right here. If I solve that, well, that'll tell me what my x is, and that'll tell me what my answer is. And you can solve it algebraically. In fact, you probably should. Don't solve this one with the graph. I don't think you would like that. But to save a little bit of time, I'm going to solve it with the graph. 133 plus x equals 0.75 times 190 plus x. Kind of zoom out till I see my answer. Oh, there it is. My answer is going to be 38. He's going to add 38 grams of pure gold. 38 grams. And, I'd probably check it to make sure it works, but there's no reason it shouldn't. Like if I put a 38 here, I want to make sure that 133 plus 38 equals, put a 38 here, just put your x back in, see if it works. Put your x back in right here and here, and, see if it works. But it should work because we did the algebra, right? So, yep, that should be it. What did I say the answer was? 38 grams. That's how much he's going to be adding. 38 grams. Let me just make sure I read everything right. A goldsmith, 190 grams, 70% pure gold. How much? 75%. Yep, 190 pounds. That's it. 38 grams. Okay. I haven't seen these yet because I'm kind of taking through them as I solve them. Doesn't make for the best explanation, but that's okay. All right. Going to the next one. Sally Finkelstein has a recipe that calls for horseradish sauce that is 55% pure horseradish. At the grocery store, she finds one horseradish sauce that is 20% horseradish and another that is 70% pure horseradish. How many teaspoons of each of these horseradish sauces should Sally mix together to get 4 teaspoons of horseradish sauce that is 55% pure horseradish? So this is another mixture problem. I'm going to set up the same sort of table that I did in my last problem. We kind of zoom in a little bit. Yeah, there we go. I'm going to go amount times the percentage equals the total. You don't have to do this, but, tables kind of help keep everything straight. So let's read through our problem. It calls for a horseradish sauce that's 50% pure horseradish. Well, we don't need that quite yet. Oh, come on, man. Wait a second. It's hard to move this little thing around. So the final has to be 55% pure horseradish. We'll get that in a second. At the grocery store, she finds one horseradish sauce that is 20% pure horseradish. Okay. So I'm going to write that in there. The percentage is 20%, which is 0.20. And the other one is 70% pure horseradish, which is 70% pure horseradish. How many of each horseradish sauce does she mix together to get 4 teaspoons? Okay, so I don't know the amount of the first one. So I'm going to call it X. So she buys X amount of that. It's 20% pure horseradish. So the total amount of horseradish is 0.20x. The second one, again, I don't know how much she needs to buy, so I'm going to call it Y. And 70% of it is pure horseradish. So the total amount of horseradish in that one is 0.70y. Okay, so that's what she bought. Those two are what she bought at the store. She bought a certain amount of this, or she needs to buy a certain amount of this. It's 20% pure horseradish. So the total amount of horseradish is 0.20x. She also going to buy a certain amount of this one. It's 70% pure horseradish. So the amount of horseradish is 0.70y. And now let's pull out some more information. Let's see what you have here. The recipe right here. Let me kind of zoom in a little bit. Can I zoom in? Yeah. So the recipe calls for 55% pure horseradish. So once she's done mixing those together, it should be 55% pure horseradish. And I wish I didn't have to keep zooming out to see everything, but I do. It's the slides are too big. How many teaspoons of each of these horseradishes should Sally mix together to get 4 teaspoons? So right here, she's going to mix these together, and the final amount she should have is 4, so I'm going to put a 4 right here. She should have 4 teaspoons of that. And now I can multiply these two together to find out how much horseradish is in her final mixture. So I'm going to go over here and just figure out what that is. 4 times 0.55. Going to be 2.2. Okay. And now I'm going to see if I can make up some equations. I know I have 2 variables, so I need 2 equations. And right here's an equation. X plus y equals 4. And right here's an equation. 0.2x plus 0.7y equals 2.2. So I'm going to write that down. That's a point. 0.20x plus 0.7y equals 2.2. And then I'm going to solve that. This is your system. Remember, you can use substitution, you can use elimination, or you can graph. It just depends on what he told you to do. I'm going to graph it a little bit quicker. It'll save us some time. But if you don't remember how to do the other ones, just let me know and I'll show you how to do it. X plus y equals 4. I just type them straight in. And 0.20x. Don't forget your x's and y's. You saw what happened last time when I did that. And don't forget your decimals. 2.2. There you go. Make sure I type them in right. Yes, I did. And now I'm just going to find out where they cross. Where they cross is going to be my answer. On Desmos, you can kind of touch it, and little gray dots will pop up. You need to be careful, because one of the gray dots is the x-intercept. That's not what you want. And one of them is the, well, that's the x-intercept. The other one's the y-intercept. You want where they cross, which is right there. So let me zoom in kind of where you see it. Right there. 1.2 and 2.8. So x equals 1.2, y equals 2.8. Remember, it's looking for the number of teaspoons of 20% pure horseradish. Right here, 20%. We call the amount of 20% x. So this is your answer, 1.2. He needs to buy, or she needs to buy 1.2 teaspoons of 20% horseradish. That's going to be your answer. She needs to buy 1.2 teaspoons. Here's your answer. All right. And we'll keep on going. Oh, no. Oh, no. Oh, man. What's going on here, man? Come on, man. There we go. All right. Next one. Clearly, I could have used a better program to do this because my slides are all over the place. But that's okay. Oh, man. There we go. Yes. So let's look at this one. Right here. How many ounces of a 10% alcohol solution should be mixed with 12 ounces of 15% alcohol solution to make a 13% alcohol solution? So you can see the last 3 problems have been mixture problems. So pay attention to the kind of table I am setting up. because you can use those kinds of tables to do these mixture problems. So I'm going to do amount, that's percentage, amount, that's supposed to be a T right there, amount, percentage, PERC, is going to be your total. All right, there we go. And now I'm just going to fill in my information. Just read through it, pull it out. How many ounces of 10% alcohol solution must be mixed with 12 ounces of 15% alcohol solution? Okay, so I have a 10% alcohol solution, which is right here. I'm just going to put it right here, 0.10, 10%. I also have a 15% alcohol solution right here. I'll just put those in right now. 10%, 15% alcohol solution. And it's saying how many ounces of 10% alcohol solution. Do I know how many ounces? No. That's what I'm looking for. So I'll call it X. Must be mixed with 12 ounces of 15% alcohol solution. So it gives me that. I have 12 ounces of the 15%. And I can multiply straight across. I have this amount of ounces of this solution at 10%. If I multiply these together, that's how much alcohol I have in that mixture. 10% of my total is going to be the amount of alcohol. So it's going to be 0.10x. I can do the same thing right here. I can multiply straight across. I have 12 ounces. 15% of it's alcohol. If I multiply it together, that'll give me the amount of alcohol in that mixture. So it's going to be 12 times 0.15. It's going to be 1.8. I'll put it right here. There's going to be 1.8 ounces of alcohol in that mixture. And let me keep my point information. How many ounces is this? I already got that. To make a 13% alcohol solution. So when it's all said and done, and I mix those together, I'll have a 13% alcohol solution. I also know that I am going to have, in my amount, I'm going to mix this with this number of ounces and this number of ounces. I'm going to mix them together. So together I'm going to have X plus 12. I'm mixing them, add them, that's how many ounces I will have there. So it's going to be X plus 12. And now, if I go straight across, this is how many ounces I have of my mixture, X plus 12. This is the percent that's alcohol. So if I multiply them together, that's how much alcohol will be in my final solution. So I'm going to go ahead and multiply this together. It's going to be 0.13 times X plus 12. That's how much alcohol is in my final solution. And now I need an equation. Here I only have one variable, so I only need one equation. Remember in my last table I had two variables, therefore I needed two equations. Here I just have an X, so I just need one equation. And right here's my equation. 0.10x plus 1.8 has to equal this. Okay, this plus this must equal that. So I'm going to write that down. 0.10x plus 1.8 equals 0.13 times x plus 12. And there you go. All you have to do is solve that. You'll want to do it algebraically because I know he doesn't want you to do this on a graph, and you know how to do that algebraically. But I'm going to go over here and type that into a graph to save a little bit of time. 0.10x plus 1.8 equals 0.13. And make sure I'm typing these in right, because if I didn't, we ain't going to get the right answer. But, yeah, I'm trying to be careful here. 0.13 x plus 12. So I'm going to find my answer. And there it is, 8. So remember, you do that algebraically. Don't do it on the graph. He doesn't want you to do it on the graph. But I just did it at the same time. So my answer is 8. Well, I think it is. X is 8. Let's see what they were looking for. They were looking for the amount of 10% alcohol. There's my 10% alcohol. I said the amount is X. I just solved for X. So yeah, the X that I found will be my answer, which is going to be 8 ounces. 8 ounces is my answer. 8 ounces is my answer. And again, you might want to check, put the 8 in here and put the 8 in here. And it should come up to the right thing, 2.6, 2, 20, 20. Yep, it does. So you're good. I mean, why wouldn't it, right? We just solved it algebraically. But you just want to be careful. But that's your answer, 8 ounces. 8 ounces. And I always lead through the problem one more time, just make sure I got it all. And I didn't leave out anything. 10% alcohol solution must be mixed with a 12%. Must 15% alcohol, 12. Yep. Got it. Multiplied. There we go. X plus 12. 13%. Yep. Okay, we're good. That's your answer. And now, keep on going. Is this it? Yeah, this is the final one. Okay, here we go. This looks like a distance, rate, time problem. I see an airplane, so let's read through it. An airplane took 3 hours to fly 1,200 miles against a headwind. The return trip with the wind took 2 hours. Find the speed of the airplane in still air and the speed of the wind. Okay. So we're trying to find two things. The speed of the airplane and the speed of the wind. I'm going to call X the speed of airplane. I'm going to call Y speed of the wind. Those are the two things we're trying to find. I'm going to set up my table. Distance, rate, time problems always set up in a table like this. Distance equals the rate times the time. Always do your distance, rate, time problems like that. It'll make it a lot easier. Distance equals rate times the time. And now I just pull out my information. An airplane took 3 hours to fly 1,200 miles. 1,200 miles, that's my distance. 1,200 miles. And it took 3 hours, so that's my time. My rate, let's think about the rate. He's going against a headwind. That means he's flying into the wind. Think about if you're running, and you're running, let's say, 10 miles an hour, and you're running into a wind. That means you are running into the wind. It's pushing against you. It's slowing you down. The wind is blowing 2 miles per hour. Well, if you're running 10 miles per hour and the wind is pushing you back 2 miles per hour, you're actually going 8 miles per hour. The wind is going to slow you down. So it's going to be 10, the speed you're running without the wind, minus the wind speed, which is 2. It's going to be 10 minus 2. Well, it's the same thing is happening here. It's going to be the speed of the airplane, which we called X, minus the speed of the wind. Okay? Speed of the airplane minus the speed of the wind. That's going to be your rate because it's going into the wind. It's slowing it down. And then it does a return trip. Well, it's returning, so it's going the same path. The distance doesn't change. It's just going back the path that it went out. So it's still going to be 1,200 miles. It's going to take 2 hours. That's 2. And the rate. Well, this time it is going with the wind. Okay, so it's not pushing into the wind. The wind is at the back. So think if you're running and the wind's at your back, it's going to make you go faster. If you're running 10 miles per hour without the wind and all of a sudden the wind starts blowing 2 miles per hour, you're going to be running about 12 miles per hour. So that's what we're going to do here. Speed of the airplane plus the speed of the wind. All right. Find the speed of the airplane in still air and the speed of the wind. Okay. So remember, distance equals rate times the time. Distance equals rate times the time. So we have two variables, so we need two equations. And we can set up two equations. This times this equals this. This times this equals this. This times this equals this. Rate times time equals distance. So I'm going to do that. These two together, when I multiply them, I'm just going to kind of mix up the order. 3 times x minus y. These two multiplied together equals my distance, which is 1200. I also have another equation, two variables. I need two equations. Here's an equation right here. This times this equals that. 2 times x plus y equals 1200. All right? Those are my two equations. And, you know, just like the other ones, if he told you to solve it algebraically, well, you got to solve it algebraically. You're going to have to use substitution and elimination. If you don't remember how, just let me know and I'll tell you. I'll make a video showing you how. I'm going to use a graph to save a little bit of time. Going to go right over here. And I'm going to type it in just as I wrote it out. 3 times x minus y equals 1200. And the other one is 2 times x plus y equals 1200. Of course, when you're graphing them, where they cross, that's your solution. So, you know, I'm going to find out where they cross at. Oh, probably right here. Yep, right there it is. 500 and 100. Y equals 100. Remember what we said, x is the speed of the airplane. So what did it ask for? Find the speed of the plane and the speed of the wind. So the speed of the airplane is 500 miles per hour. And the wind that's a really fast wind, isn't it? 100 miles per hour. And that's your answer. I'm just going to see if it makes sense real quick. Kind of plug in my head and kind of see what we got going on here. If it was going 5, it's going 5, 6, 5. Then if it's going 5, 4, 4, 3, 2. Yep, that's it. That's your answer. And is that it? Is that it? Did we do them all? I think we did. Oh, yeah, we did. Yep, that's it. Again, when I was working these out, it was kind of like the first time I saw it. So make sure when I type those into the calculator, I didn't type them in wrong. Because if I did, well, the answer's not going to be right. So make sure what I typed into the calculator when I was solving the equations, I didn't leave out a decimal or anything like that. You know, I don't think I did. I was trying to be really careful. But those are your answers. Wasn't the best explanation because, again, I was working them out for the first time. So if you're confused, let me know. I'll make you another video. But that's it. All right. So I'm going to turn this off.